And they've got it just to show the difference. It shows you a couple of things. Do you see why the density of solids tend to be high? Because the particles in each one of those things represents an atom of your material here. Okay, so they're close packed. You can't get them much closer together than that. That's why they have a high density. When you look over here at the gaseous state, a gas is really mostly empty space. That's why gases are so compressible. You know, you can squeeze them into a smaller volume, where solids you really can't. They're as close together as they can be. And then here we are with liquids. It's not spread out like the gases, and see, it doesn't take up the whole volume, but see, the gas takes up the whole volume that you've provided to it. So definite volume, definite shape. Here we've got a definite volume, and the shape would be different if we poured it into something else. But see why the density would be intermediate for these? They're not as close packed as a solid, generally, but they're not as spread out as in the gaseous state. This also shows you something else wonderful that you'll hear later, is what do we believe they're doing as far as motion? For gases, our theory, the kinetic theory of gases, kinetic is of motion, fantastic amount of straight line chaotic motion. They bounce into each other, they bounce right back, they hit the wall, they bounce right back. So a tremendous amount of motion. When you get to the liquid state, you got a little bit of rolling and tumbling, some limited motion, and over here in the solid state, if you're not at absolute zero, meaning minus 273 Celsius, you've still got a little bit of vibration, so a tiny bit. So you can see again the extremes. Low motion, medium motion, a tremendous amount of motion. And so that is a part of, this is the introductory part, and then the questions. You can see what the questions look like. And so what they're asking you to do, okay, we've got this first. Now we're talking molecules. We're talking compounds, because you got different colors of the little spheres here, and that's how they indicate. Okay, so if you've got this, solid, liquid, or gas? Solid, for sure. What do you suppose we have here? Liquid. They weren't very cagey because they didn't even change the order, did they? Okay, and so this is gas. So you have a series of questions like that. Now let's see if we can run this backwards. So that was section 1-3. And then there was another one I wanted to show you too, if I can get back to the assignment list. While I have this up, because you get timed out after about an hour if you don't do much with it. So let's see, that was, okay, 1.2b. I don't think I've shown you that one. This takes us back a little bit. Okay, this one, I probably should have started with this one. This is not talking about what state it's in. I mean, they're spread out like they're all gases. But each little circle represents a type of element, or an atom of that. So what they're wanting to know here, on this first one, would this represent an element or a compound? Element, for sure. And then you see this purple guy with 3 blue guys around it. That could represent ammonia. NH3, it could. So what is that, element or compound? Compound, for sure. Now, this one's a little bit trickier. You got 3 guys. This could be like ozone, O3. It's all the same stuff. So they want you to say which, element or compound here? Element. They want you to say element here. Okay? So that's 2 of the types of problems from this chapter. So, could anybody think of, though, when I said usually, density, let's go back to density. Solids have a really high density, liquids have medium, and gases have really low. Can anybody think of an exception to that? Ice. Ice, that's a good one, because ice floats. If it has to have a density less. Ice, solid water, the density is less than the liquid water, but ice is really peculiar, because when it freezes, it sets up this crystalline lattice that spreads out the water molecules, gives it more space, so yeah, it floats. That's a good exception. Can anybody think of another exception? Any liquids? Okay, I don't think the density would change that much for the boiling water. You're moving into gas.
Oh, you can't put like whiskey in a freezer. It won't freeze.
Well, that's a different, just a different.
Give it
And
away
how
with
do you know
alcoholism,
that? And why were you doing that? Okay, think old-fashioned thermometers. Mercury. Mercury. That's a liquid at room temperature and pressure. Okay, the density of liquid water at, again, normal temperatures and pressures has a density of 1 gram per milliliter. Okay? Copper is about 8 or 9 grams per milliliter. That's solid copper like the wiring in your house. Okay. Mercury has a density of 13.5 or 13.6 grams per mil. In other words, liquid mercury is almost 14 times denser than water. Okay, so it's weird. And some interesting uses for those of you going into the health professions. Years ago, and I can't tell you how many years ago, I'd have to look it up, that if you went to your doctor and your complaint was constipation, okay, one of the cures back in the old days, you drank some liquid mercury. Okay? Now, I mean, it's a liquid, so you can get it down. The idea is it's so dense, you know, if there's anything down here that's not moving for you, this is so dense, it's going to be like Roto-Rooter and just push it on out. Now, you might wonder, why didn't they kill their patients? Because you've heard about how toxic mercury is. Again, don't do this. Don't do this. But why they didn't kill their patients that way is because the mercury would have to dissolve in the body to be absorbed to kill them. It's really mercury compounds that are hazardous, just like the arsenic story. So yeah, they drank it, and it worked or it didn't work, and eventually it's going to find its way out. Okay? Now, within the last 20 years or so, I know they're still using this, but they don't make you drink the mercury. They put it in a packet. Golda Radner, who used to be on Saturday Night Live, she's now deceased, but she wrote a book after she got cancer. She wrote a book about her treatment and, you know, her feelings during her treatment for cancer. Okay, one of the problems she had along the line is they thought she had a kink in her small intestines. And they really didn't want to do surgery to find out. And so what they had her do is swallow this little packet, tied up or somehow, a packet of liquid mercury. Same idea. See, it pushed through and hopefully worked the kink out. But she said in her book that, unfortunately, the packet broke open on its way through. Okay, and she said, I made a discovery, a medical discovery, that the sphincter muscle at the end of the line is not strong enough to hold mercury back. She's just walking through her house, minding her own business, and splat on her rug. I mean, you know, liquid mercury came out. So something really, really dense and liquid like that is just going to happen. Okay, so it's an interesting use of mercury, and if any of you are in health professions, find out if they're still feeding people packets for that kind of treatment. I don't know if that's up to date. Another use of mercury I've heard is boxers illegally put mercury in their gloves to hit people harder. Now, you got to be pretty strong to have your glove in the air and have it full of mercury, because that's really a lot of weight there. So I don't know if they still do that. But one of my students was telling me, I looked it up on the internet because I didn't believe it. And yeah, they do. At least they used to put mercury in boxing gloves so that you had a little bit more power in the punch.